Hey guys, I'm back with another video. So today I have come up with another two-dimensional list problem solving tutorial. The question is quite similar to my last Python problem solving video related to that removing islands question, but there is a small twist that can make things more complicated. So I recommend you to first go check out that video. Just click on the notification at the top right corner of the video. So let me explain you the question first. You are given a two-dimensional array or a matrix of potentially unequal height and width containing only zeros and ones. Each zero represents land and each one represents part of a river. A river consists of any number of ones that are either horizontally or vertically adjacent but not diagonally adjacent. The number of adjacent ones forming a river determine its size. Note that a river can twist. In other words, it doesn't have to be a straight vertical or a horizontal line. It can be L-shaped or T-shaped, for example. So all you have to do is write a function that returns an array of the sizes of all rivers represented in the input matrix. The sizes don't need to be in a particular order. So here's the sample input. Yeah. So let's talk about this particular input in a detailed way. So as we can see a 5 by 5 grid of zeros and ones, we have to figure out all the connected ones and find out their length. All these red highlighted ones are together and connected either horizontally or vertically. All the individual ones are also counted as river. Also, we can also see an L-shaped figure. Now just add these lengths of all these highlighted rivers in a list and print it. This was a simple example. So now let's take a bit complex one. So yeah, now let's talk about this bigger example. So in this example, after looking at the output, you might be thinking, how the hell did this 21 come from? So don't worry, that is normal. So these 21 highlighted ones are all connected. So this part will be tricky because now the rivers can also be branched. So now let's get back to our coding. So here let's first analyze and think how we should go about it. So we can loop through the whole two-dimensional list from left to right and top to bottom. In case we found a 1, we can apply a recursive function that could find all the adjacent ones to it. Now there will be a lot of repetition, so for that we can replace all those ones into 2's. Otherwise we may count the same river many times. And we can make a list in which we will keep on appending ones as we find a 1, and as we go through the recursions we can add 1 to that element of the list. We will make sure that we are not going back to where we came from while counting the adjacent ones, as it will lead to a lot of overlapping of cases. I mean to say that in case we chose a 1 and we are now checking for a 1 at its right and we found it. Now for that that one we shouldn't go again towards the left direction, and we should check only up, down and right direction in such a case. So now let us begin with the sample input. So this was the sample input I was talking about in the illustrations. So the expected output should be 2 1 21 5 2 1. So now let us see if we could make a code that could print the same output. So now, as I have told, we will have to loop through the two-dimensional list. Here I represents the y-axis and j here will be our j, and j will represent our x-axis. It is important to clear the things in the beginning only so that we do not face any bugs afterwards. So now if we see that xij is equal to 1, then we will have to check for its adjacent ones. But now let's first make the things more clear. While providing the indices, we will have to provide the y-axis first and then the x-axis. So as we can see, we have provided the I, that is the y-axis first, and then the j, which is the x-axis. And now we will have to make a function that could find out its adjacent ones. So now, as I have told, that we will have to append a 1 to our output variable. So let us make an output variable right in the beginning, and this will be the list of our output, and let us append a 1 to it. So since there is a 1 here, so this means that we have found a river and its length is at least 1, of course. So now we will have to make a function to find the adjacent ones. So if you have seen the last video, you might find it easier to understand, but I'll explain it anyways. So here we will have to just input the indices. So our int variable will take the x value first and then the y value. It will be in a list format. I'll just show you how it would look. So check adjacent for j comma I. So let us make another variable which will represent our in what directions we will have to go. So directions. So our directions would be either 0 comma 1 or 1 comma 0 or minus 1 comma 0 or 0 comma minus 1, and 0 comma 1 represents downward direction, 1 comma 0 represents towards the right, and minus 1 comma 0 represents towards the left, and 0 comma minus 1 represents towards the in upwards direction. So if we found that if our x variable has indices 0, the y-axis should come first and then the x-axis. If it found that it is equal to 1, then we will just replace it by 2, and if it is already 2, then it means that we have already counted it, and in case it is a 0, we just have to ignore it, and in case it is a 2, still we have to ignore it because we have already counted it in our output variable. So here we should write output instead of vals so that we can make things more clear. Yeah, so else we just have to break the function, and now we will loop through our directions variable for I in D. So now we will make our new x and y values. So our x value would be, let us name it q, and its x value would be the indices 0 plus the I0, as I have told here. Let me make things more clear. Here it will be x comma y, and here we will have to define our new y variable as well. So it would be the sum of their y values. And now, since we can also go outside the list, for example, we are at the last row and we want to check in the downwards direction, so there is no such row below it, so the program can show an error in such a case. So we will have to consider those cases as well. So we will have to use our try except cases, and if we see an error, we just have to pass it. And now if we found a 1 at this location, our p represents the y-axis and our q represents the x-axis, so we will provide the y value first and then the x value. And then if we found that it is equal to 0, then we can just check if it because the indices of a list can also take negative values, and negative values, what they do is, for example, we are talking about x minus 1, so this would be the last row, and we just don't want to go to the last row. After we want to check in the upwards direction to the first row, and the last row is not towards the upwards direction of the first row. We just have to check in case we are trying to find out such cases which are outside the list. We just have to end the function. And now we have made our output variable and we have appended a 1 here. So now we will, as I have told, that -1 handles the last value we have added to the variable, and we will just add a 1 to it because we have found another 1 in the river, and this will increase the length of the river. And now we will check the adjacent to this as well. So for now this, okay, so as I have told that we cannot go if we are going towards the right direction, we don't want to go again towards the left direction. So in such a case, what we can do is we can for a usual case, what it would be, here we will provide the d value. So here I think we should provide another variable which would be L. Here L would be in the format x comma y, and it would be similar to d only, just some of the elements of the d would be removed. So here also we will provide d as it is, because it is not a continuation to another one, it is an original one what we have found. And now originally, if it was an original one, we would have just used d, but since it is a connected one, so this means that we will have to remove a particular value, that is if we are going towards the right direction, then we will have to remove that value which takes us towards the left direction again. So in such a case, I in d, if I is not equal to the inverse of the okay, instead of I we can take j, just to prevent the overlapping of the variables. If j is not equal to the additive inverse of our I, yeah, it looks correct, and then we can provide the indices of our new variable. So we will provide the x value first, which will be q, and the y value afterwards. And now our code looks perfect. We can now just print our output and see if we see an error. It should give the expected output is this. We can just write it here, expected output. And now let us run the code. And yeah, we are getting the expected output. And now we have made the solution. So thank you guys, please like, share and subscribe. I would appreciate if you comment down in the comment section and tell your reviews about the code. So please follow me on SoloLearn as well. I'll share the link for the code in the description, so please check it out. Thank you.